We are now recording. I'm going to share my screen. I have way too many screens going on here. All right. So today, I'm going to introduce to you the units that we will use in this class. If you have taken a class from me before, which almost all of you have, you know that I have a particular hatred for the imperial measurement system, right? So what do I mean when I say imperial measurement system? Davis, what do I mean by imperial measurement system? Well, what do I hate about measuring things? Using inches, yep, nailed it. Yeah, so there are two commonly, quote unquote, commonly used measurement systems in the world. One of them is used by 2 countries officially. The other measurement system is used by every other country. We, in the United States of America, are one of the 2 countries that uses the British imperial system. All right. Zoom people, I'll be back. The British imperial system, many of you wrote this down, I'm sorry. Today is the 31st? 31st. Okay, SI units. So in your notebooks, I would recommend opening up your notebooks because we are going to be taking notes today. Notebooks. Online people, you can have a notebook if you like. It's also easy to use a Google Doc. For those of you who are here in person, you can also use your laptops to take notes on a Google Doc because you will be submitting these notes online anyway. Here's the issue, and I'm looking at you, Miguel. Why you? You know why.
Well, it's not like I've been playing on it.
Yeah. It's not that I haven't been playing, like paper, Sure. Okay, so you can use Google Docs to take notes if you like. You're good.
Does everyone in here have their photo taken?
I think so. Yeah, I said essential yet, so that's good.
Thank you.
Mr. Post, you're getting your exercise today, huh? Oh man, poor guy. Without the PA system, he's got to go to like every single class. Good morning, Da Vinci! Yeah, all right. So, yeah, so you'll be submitting your notes either as a picture of your notebooks. I know that's going to be a hassle. Or as a Google Doc if you are taking your notes on as a doc. Okay? Just let me know.
What's this class called?
What is this class called? It's called chemistry. All right? So, let's talk about the SI units of measurement. So I believe that SI stands for Standard International, which is French. Don't quote me on that, I'm probably wrong. But the international standard for measuring units is what we call here in the United States of America the metric system. Okay? The metric system. So we're going to talk about what units we use for different things, all right? Let's start off with size. You can also call this length. What do we use? What is the base unit? What is the base unit for size? Daniels?
So we're using for copy.
In this class, the correct unit of measurement, not the idiotic one.
Oh,
Shelby. Meters. Okay? Meters is, we use the abbreviation M. Okay? We use the abbreviation M. Let me make this wider. I can't, that's better. Okay, size or length, we use meters. That is the abbreviation M. How big is a meter by show of hands? It's about this big. Okay? It's about this big. I could get a meter stick and see exactly. I was pretty close. This is a meter, right? Meter, okay? Meter. All right, what else can we measure in science? Hannah, what else can we measure? Huh? Weight. Okay. Weight. I am going to use mass. Weight is an interesting situation, and we will talk about that. Mass. So mass and weight are actually two different things. Okay? And we'll talk about that in just a second. So, but what unit do we use for mass? Yes. Grams. Grams. Little g. Okay? We use grams. Does anyone know how much a gram is? Like how much it weighs? How much? Any ideas? Catch. It's a paper clip.
Oh, it's you threw air at me.
A single gram weighs about as much as a paper clip.
Oh, you did throw something at me.
I did. I threw that paper clip at you. You can throw it at me now. Thanks, buddy. Okay. A gram weighs about as much as a paper clip here on Earth. So now that we're talking about that, what is the difference between mass and weight? Miguel?
Mass is how compact something is.
A mass is what?
How compact.
Compact. So that is a very good, I mean, we use mass in how compact something is, but what you're measuring is actually density. Yeah. Yes, yes. Okay, for those of you who could not hear, because masks, Eleanor is absolutely right, okay? Mass is just how much something, how much of, like, it's hard to say like stuff, but it's kind of stuff. It's the amount of matter, okay? It's the amount of matter. Weight is dependent on gravity. Right? So I weigh a certain amount here on Earth. I weigh a different amount on Mars, about 33% of what I weigh here on Earth. However, my mass is the same. So I have about 95 kilograms of mass, okay, or 95,000 paper clips worth of thickness. Okay? My weight in the international standard of units we use for weight. So what I want you to do is I want you to cross out weight in your notes, okay? So that it will help you remember. Weight is the same thing as a force. Weight is a force, and that is measured in what? Does anyone know how we measure forces in the international units? Yeah. Newtons. Absolutely. It's newtons. Okay? We use newtons for force. So I have 95 kilograms of mass, right? Well, I have approximately 911 newtons of weight here on Earth. So I'm going to talk about the forbidden measurement of pounds for a moment. Pounds, is pounds a measurement of mass or weight? Does anyone want to take a guess?
It's a currency.
It is a currency in England. Yeah, Ben. It is a weight. Yes, it is not mass, it is a weight. Okay? So I weigh approximately 205 pounds. Okay? I don't care that I can tell you all that. I weigh approximately 205 pounds. I have a mass of 95-ish kilograms. Okay? Depending on the day and whether or not I had a milkshake the night before, which I did not last night, but I do sometimes. So, okay. Questions about mass and weight and force. So weight is a force. I want you to just remember that. Weight is a force. It is gravity interacting with matter. Okay? No questions on that one? All right. What else can we measure? Now we're going to get, yes, volume. Perfect. We could use volume. Hunter, do you happen to know what the unit is for volume? It is liters. If you want to be really fancy, you can spell it that way, liters. But if you want to be American, it's this way. Merca, F yeah. All right. Liters, lowercase L, liters. Oh, wait, is it lowercase? Or is it uppercase? I think it's uppercase, isn't it? I don't know why they do this to us. Pretty sure, yeah, I'm pretty sure that it's capital L. I don't even know why they made it. That's actually a really good question, Ben. Why do you do this? Okay, so yes, capital L. What's up? Here you go.
America should make its own unit of time.
The Patriot Hour. Okay, so liters. Well, first of all, so newtons. Just to let you know, newtons is super easy to calculate. Okay, super easy. You take the mass in kilograms and multiply it by the acceleration here on Earth. Okay, so if you want to know how many newtons you weigh, you just take your mass in kilograms and multiply it by 9.8. Because that is the interaction of mass and weight. It is mass multiplied by force equals weight. Yeah, Ben. So here on Earth, it's pretty nice that we can just use a regular scale because they're all calibrated. So all scales that measure in kilograms are calibrated to measure here on Earth. So you can stand on it, and really it's measuring weight, but it can tell you what the kilograms are, okay? So if you have a bathroom scale, which I happened to just throw one away the other day because I realized that the one that was provided for this classroom was only in pounds, so it's essentially useless to me. If you have a bathroom scale, it should have the numbers for kilograms along with pounds. It should also have a setting. If it's a digital scale, it should have a setting like on the back to flip between kilograms and pounds. So you can do that and then just take your kilograms, multiply it by 9.8. That gives you your Newton weight. Yeah.
So I have a doctor and I want to know how much I weigh in pounds.
Uh-huh.
And she told me to multiply like what I was by 2.2.
Yeah.
So you could,
Yeah, so a kilogram is equal to 2.2 pounds.
so you could divide it.
Yeah, but I would just prefer that you learn kilograms. Just like I have done with you in the past, where I made you calculate things in Celsius. Or who has taken Earth systems from me? Just a few of you. Just a few of you. Earth systems, we did assignments where you would have to do things in Celsius, like weather reports and so forth. Really, I just want all of you to go home and change your thermometers and your thermometer on your phone to Celsius. You will learn it. Okay, you just will, because that's the thing. Oh, well, we might as well get going here, but we'll talk about that in a second. Okay, let me organize my thoughts here because I don't want to go on a tangent quite yet. Liters. What is a liter? Anyone want to take a stab at how much volume a liter is? Ben?
I want to say, so like a 2 liter soda is the big one.
Mm-hmm.
But I think compared to a gallon, it's like 2.7 or something.
So a gallon is just slightly over 2 liters.
Yeah.
Okay. So I've got my handy dandy Powerade here. This is 0.59 liters. Okay. 0.59 liters. Couldn't see that in the video. 0.59 liters.
Just about half of it.
Yeah, it's a little bit over a half of a liter.
So is that like 12 fluid ounces compared to a gallon?
This is 20 fluid ounces. Okay. Oh gosh. Oh my gosh, guys. I think that honestly, the volume measurement in the British imperial system is the worst. I think, like, of all of them, inches and miles and furlongs and feet and like they're at least somewhat understandable. Fluid ounces. Fluid ounces, guys. It's the worst. All right. You can also measure volume in the British imperial system in cubic inches, which is just, oh, it just hurts my soul. It's really bad. By the way, this is all going to make you very angry. There are actually 2 official lengths for an inch.
Yeah.
So which one is which? Well, they both get used sometimes. So, yeah, Eleanor. But Croshaw told me. All right, because I am petty, we're gonna look this up right now. 2 official inches. Okay, let's see here. So let me pull this up here. National yard. So it is equal to 1/36 of a yard or 1/12 of a foot. But those aren't exact. Those don't equal each other. Because a foot is supposed to be 3, or a yard is supposed to be 3 feet, but it's just slightly longer. Well, like in ancient times, there was no standard, right? People, I mean, this was a cubit, right? The measurement, depending on how lanky a person was, a cubit could be like the size of, you know, Davis's forearm compared to the size of Ashton's forearm, which I think are vastly different sizes, right? But that's a cubit, right? Everything was mostly just based on the human body, thus the foot, right? They standardized the foot under some English king that I made a point not to remember. So anyway, there's that. Fun times. Okay. Liters, and what else can we measure in science? Yeah, Hunter. Time. Time. This one's easy because we use this one here in the United States. I know it's a miracle. We actually use a correct unit here. It's called a second. You may have heard of it. Okay. What? Yeah, pretty much. Like in normal conversation. Just to let you know, we can also use cubic centimeters. It depends. Yeah, cubic centimeters is okay. It depends on what you're measuring. I'm looking for it. There it is. Okay. Cubic centimeters. Time in seconds. Was it in this class that we had the discussion about like 1 Mississippi, 2 Mississippi?
Yeah.
How many what? Oh, yeah. 60 beat, exactly. Well, you are a percussionist, so you should be able to, you know. I kind of have a cheat. My resting heart rate is usually right around 60, so I can just kind of go off of that. What, Brennan? Just listen to your heart, Mr. Kosha. Yeah. All right. Any other items that we can measure in science? Temperature. Yep. We will talk about kelvins in just a second. Temperature. Okay. So we will use degrees Celsius for measuring things, but for all of our calculations, we will use kelvins. A Kelvin was a dude, Lord Kelvin.
No, I'm like,
I know, I'm just kidding.
oh, that's your open secret.
A Kelvin is a measurement of temperature that is only positive, okay? So 0 Celsius is the freezing point of fresh water, right? And there are temperatures that are colder than that, right? In fact, we experience them every year for most of the year, I feel like. Winter feels like a long time, right? Kelvins has no negative measurement. 0 is 0. So remember what we are measuring with temperature. What are we measuring with temperature? Who recalls? What are we measuring with temperature? Vince? How fast molecules move. Okay? You're really just measuring the kinetic energy of molecules on a large scale. Okay? There is a point at which those molecules don't move at all. It is called absolute 0. Absolute 0 is 0 kelvins, and it is not degrees Kelvin, it is just kelvins. Yes, 0 Kelvin is really, according to the laws of physics, essentially impossible to achieve. Because atoms are always shaking a little bit. I believe that we have gotten under 1 Kelvin. And at that temperature, 1 Kelvin, literally everything is solid. Okay, so like oxygen is solid, nitrogen, which is in the air, is solid. So you can make air solid. Okay, so temperature. We use degrees Celsius, and we also use kelvins. This is actually really nice because degrees Celsius is the same amount of measurement as degrees Kelvin, as kelvins. So if you can think about it like this, all right? And I'm going to attempt to draw something on this, and it's not going to be pretty, okay? Just to let you know. Why does it only grow diagonally? Can I not make it grow? Well, whatever. Okay. I'm going to attempt to draw something. It's going to be disgusting, but so this is, if this is 100 degrees C, no, and this is 0 degrees C, okay? Fahrenheit looks like this in relation to this. Let me erase this. Fahrenheit looks like this. That 0 is down here, 0F. And 100 is like here. Okay? So it's actually all right. And then if we do kelvins, Kelvin 0 is here, and 100 is here.
It would like actually to scale, would tell it to be like down on the board.
No, not really, because 0 degrees Celsius is 273 kelvins. Okay, so 273 kelvins is 0 Celsius. But the change of 1 degree between 1 degree Celsius and 1 Kelvin is equal. So if we go up by 1 degree C, we go up by 1 Kelvin. Does that make sense? They're the same unit size. Fahrenheit, the unit size is smaller. But we're not going to deal with Fahrenheit because it's idiotic. Yeah.
Why did they choose for 30 degrees Fahrenheit to be where water boils when water freezes?
Why didn't they choose?
So what is Fahrenheit based?
Fahrenheit is based completely on human comfort level, which is completely subjective, right? It's completely subjective. Hey, do you feel cold? Well, I'm from Siberia, so no. Hey, do you feel cold? I'm from Ecuador, so absolutely. Fahrenheit. Yeah, exactly. Yeah, it's so stupid. Okay. Questions on any of that?
Is there anything more American than measuring it based on how much we like it?
On how you feel. Yeah, so if you couldn't hear the computer, Emma just asked, is there anything more American than measuring a scientific unit on how you feel about something? I feel like this should be like 100 because it's really hot. What are the? Yeah. Okay. So that's that. All right. Questions on any of those? What time does this class end? 10:55. All right. We have 30 minutes. We good? We good. All right. So now there is one final measurement that we will use in chemistry that you need to understand, and that is moles, which is the amount of stuff. Okay, it's literally like the amount of stuff. Moles, the amount of stuff. Moles. Oh, this is going to take forever. Are you kidding me? All right, this is, well, screw it. I'm just going to make this bigger again. Oh, well, that doesn't work either. Dang it. Oh, you all get to enjoy me erasing this over a long period of time. Okay. Moles is the amount of stuff. It is literally the molecular count So if you were able to literally see molecules in this water bottle, and if you could count them, that's how we measure moles. The amount of molecules. Spoiler alert, it's a big one. And I mean a really big one, okay? So, have you ever heard of the term mole before? Yes? Moles. So moles is capital M. Or they just can do MOL. Okay. Okay. So does everyone have this down in their notes? You should, probably. And by the way, if you are not organizing your notes this way already, I would definitely recommend organizing your notes by like what is written on the board and then what is talked about in that section, on the side or underneath it or something like that. Maybe in a different color or highlighted or something like that, just so you can have a way of organizing your notes. Okay. Moles. So I'm going to erase all this, and you're going to be upset about it, but whatever. We need to talk about moles. Okay? A mole is equal to 6.022 times 10 to the 23rd power molecules. Times 10 to the 23rd power. 6.022 times 10 to the 23rd.
Then that'll always have the same number, right?
What?
If that's like just the equation, where's like the variable? Or like how do you measure it to get
So the number of moles, so if you want to figure out how many molecules something is, you take the number of moles as X. Well, let's do Y. Okay? Y equals the number of moles. Okay? So you take Y and multiply it. If you want to figure out the number of molecules, you take the number of moles and multiply it by 6.022 times 10 to the 23rd. Okay? That is the number of molecules. So if we were to write that number out, it would look like this.
Oh,
That's a doozy. (602 sextillion. No, septillion. 602 septillion.
18 zeros?
No.
Oh, wait.
We start here.
20.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Because you start where, so you start where the point is, right, in the number. You start there. So it's 6, and then a 0, and then a 2, and then another 2, and then 20 zeros. Yep. 602 septillion, that is 1 mole. Okay? It is a truly ridiculous number.
So,
Okay. Yeah.
how is this going to be useful in chemistry?
Oh, we will use it like every day. Okay. So this here, this amount of water, we're going to talk about this more next time, but this is useful because we can understand how many particles are in any given thing using the weight of the atom for that thing, or the weight of the atoms in the molecule, and then that, okay? So that is a standard unit. Those are all of the standard units of measurement. Are we all familiar with those? We good? Okay, we'll talk about moles a heck of a lot more later, all right? Questions about moles, anyone? Carissa, Melissa, Rose, Ivy, anyone that's online? Any questions? Any questions for the in-person peeps? Elizabeth? We could figure it out. Do you want me to figure it out right now? All right, let's do it. So this is 591 milliliters, okay? So the question was, if we fill up this water bottle, how many molecules of water would there be? So let's figure it out. 591 milliliters. Opa. 591 milliliters. Okay? And we'll talk about milli and all the prefixes in just a second. Yeah. A milliliter of water, this is actually super handy. A milliliter of water weighs 1 gram. Okay? So that is 591 grams. Okay, 591 grams of water. Okay? So what we can do now is we can figure out how much each atom weighs and what we're made out of. So what's the chemical formula for water? You should all know this. H2O. Dihydrogen monoxide. We're going to talk a whole crap ton about how we name chemicals and so forth. H2O, which means that there are two H's, and one O in each. One O in each molecule. Okay? Oxygen has a molecular weight of, what is it, 16? What's the number underneath that? Pretty sure it's 16. 15.994, yeah, it's 16. Okay, oxygen has a molecular weight of 16. So there is, or an atomic weight of 16. So there is one oxygen atom, which is 16 AMUs, which is atomic mass unit. We'll talk about all that later. And hydrogens each equal 1 AMU. Cool. So if we have two hydrogens and one oxygen, how many AMUs does each molecule weigh? 18, right? Because we have 16 plus 2 ones, that gives us 18. So a water molecule weighs 18 AMUs. Okay? Well, if this is where it gets cool. If we multiply the AMUs by Avogadro's number, then we get grams. Oh, sorry, I should explain what Avogadro's number is. Avogadro's number is 6.022 times 10 to the 23rd. It's the number of moles. Okay? Just some dude named Avogadro figured out how many Avogadro. Not avocado, Avogadro.
You see where I'm confused?
I can see where you would be confused. All right. So that means that each mole of water equals 18 grams. Okay, so if we take the weight of each molecule and we multiply it by Avogadro's number, that gives us grams. So that means that we have 18 grams per mole. Okay? And how many grams do we have? 591? 591 grams divided by 18 moles. I don't want to walk all the way over there to go get my calculator, so it's calculator time on the phone. 591 divided by 18. That gives us 32.83 moles. 32.83 moles. We multiply, oh, I will need a calculator for this though. Because I've got to multiply it by Avogadro's number. So what was it? 32.83 moles? Not molds, moles. Okay, and then if we take that number, 32.83 multiplied by 6.022 times 10 to the 23rd. That gives us 1.977. 1.977 times, 1.977 times 10 to the 25th molecules. What? Well, because we multiplied 32.83 by 6.02 times 10 to the 23rd. So that means that we have 1.9, which looks like this. That number looks like this. Are you ready? 1977. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25.
You put comas in those?
I sure can. I believe it's pronounced comma, but I could put some comas in there. I mean, a few of you are in a coma already, so.
25 zeros?
I put 25 digits after the 1 point, after the 1. So this is where we start, Shelby. This is where we start, okay? Does that make sense?
So
Which is, let's see here, this is million, this is billion, this is trillion, quadrillion, quintillion, sextillion, no, it's 19 octillion. So in this water bottle, if I fill it all the way up, we have approximately 19 octillion molecules of water. Isn't that awesome? It's pretty cool stuff, okay? Pretty cool stuff. We will do a whole crap ton of that later. And when I say crap ton, I mean a crap ton, okay? Questions on any of that we just did? Elizabeth wasn't anticipating how much that was going to be. Don't worry, I know that was confusing. We will work our way up to working that on your own later. Okay? Oh, Leighton's supremely competent. Yeah, we're good. Okay, last thing that I want to cover today with you all are the prefixes of the SI units. Okay? So what do I mean by prefixes? Anyone? It's how many. Okay? It is how many. So without a prefix, no prefix, it is simply equal to 1. Oops. Equal to 1. Okay? So a gram is a gram. All right? I know that seems supremely obvious, but we got to start somewhere. A gram is a gram. Okay? There are so many different, hey there, buddy. There are a bunch of different ways to use the prefixes. There are a bunch of prefixes, I should say. We will use just a few of them. There are technically hectos and decas. We're not going to really use those because those are 10 and 100 times. They're not all that useful. So going up, actually, going up, we will mostly use kilos, which means what? Huh? Anyone? Kilo. What? No. Kilo. So a kilogram, how many kilograms is equal to 1 gram? It is 1,000. Ben, it's either 10 or 100 or 1,000. Okay, a kilo. Sorry, that shouldn't have the S there. It should just be kilo. A kilogram is equal to 1,000 grams. A kilometer or kilometer is equal to 1,000 meters. A kiloliter is equal to 1,000 liters. Got it? Okay. We will use this one every once in a while. Mega. If none of you have played Mega Man, then I feel bad for you. Especially Mega Man X. Ooh, that stuff's good. Mega. How many grams are in a megagram? 10,000 is a good guess, Liz? 10,000, 100,000, it is 1 million. Okay. We will not use that all that often, just to let you know. But every once in a while. You probably have heard of megabytes. Megabytes, those are 1 million bytes, which are, a single byte is a 1 or a 0. A megabyte is 1 million ones and zeros. Yeah, Leighton? There are many after that. It is giga or giga, some people say. Giga is 1 billion. Does anyone know what comes after giga? Tera. I'm not talking about your cousin named Tara. It's T-E-R-A. Well, I have a sister named Tara, so. A tera is 1 trillion. All right, now I'm going to be super impressed if anybody knows what comes after tera.
Don't put that expectation on me.
It is peta. Okay? So these go in orders of 1,000. Okay? So a kilo is 1,000, whatever. So a kilometer is 1,000 meters. A megameter is 1,000 kilo, or yeah. A megameter is 1,000 kilometers, or equal to 1 million meters. Does that make sense? Okay. A terameter would be 1 trillion meters, or 1,000 gigameters, or 1 million megameters. I know it's kind of confusing, but it's all by orders of 10. Okay? What is underneath 1? Some people use deci, but we're going to skip over deci. It's kind of a useless prefix. Deci is 1/10 of. But we're going to just skip over it to centi. What is centi? 100. It is 1/100th. 1/100th of a meter or a gram or a liter. This is why this system is so awesome. We can use the same prefixes for all of the units. If I am around for 1 kilosecond, 1 kilosecond is 1,000 seconds. Okay? We can use kilo for grams, meters, liters, anything. Any of the units. All right? Under centi. What can we use under centi? Any millimeters or milligrams or milliliters. That is 1/1,000. Okay? Okay. Okay. All right. Underneath milli, anyone have any ideas what is underneath milli? It is micro, which is 1/1,000,000th. One 1/1,000,000th. Okay. This is where I have to insert a special character, which is annoying, which I don't know if I can even do it here. It is the lowercase Greek letter lambda. Micrometer. Micro. Which looks like this. Maybe. Looks like that. Looks like a U with a tail. Okay. What?
What is it?
Lowercase Greek letter lambda. So yeah. Okay, questions about any of those? Pretty sure it is at least. Let me see here. I might be wrong. Nope, it's the lowercase Greek letter mu. Mu. What is lambda? Oh, lambda looks like that. Oops, my bad. I don't know my Greek letters very well. But I do know that that means micro. It looks like this. It looks like a U with a tail on it. Let me just draw it in here. Prepare yourselves. This is gonna be really pretty. Oh, I know. You're all super jealous of that.
Hey, look, I was actually able to type it out.
Yeah, I don't know. I know that you can insert special character.
Just press Control W.
Control W? For reals? No? Oh yeah. Okay. That's a you freaking jerk.
Yeah.
Ben, you got me. All right. Questions on any of that? We cool? SI units, moles.
What are we trying to say?
You hold on to your notes. You will be turning in note checks later. Okay? Frank? I do have an online version of this. It is on the YouTube that you may have heard about. That it is literally, I'm recording this right now. I'm going to upload it to the YouTube. What? I only have like 200 subs. Someday we're going to get more. Get merch. Hey guys, visit my merch store. Okay, we got some new stuff in there. Luna and Soul merch. I bet that you'd buy that. Okay.
Control W actually pulls
Okay.
up the tab.
I am, yeah, that's what I thought. Okay. I'm going to stop the share. Okay. Nice work, everybody. No assignment today. I'll make an assignment next time. And I will talk to y'all later. Bye.